Okay, so good morning everyone. Senan this side, and in this video we are going to solve this LeetCode daily problem, which is what? Different ways to add parentheses. So this is LeetCode 241 and this is a medium level problem, and this is actually deserving of a medium level tag. So what given to you is a string expression of numbers and return all possible results from computing all the different possible ways to group numbers and operators. You may return answer in any order. So the answer would fit in a 32-bit integer, and the number of different results does not exceed 10 to the power 4. So at max you will have 10 to the power 4 possible ways of putting parentheses, but your value would inside 32-bit integer. So that is fine. You don't have to consider any long or something like that given you're using C++. Okay, so we'll look at the test cases, but just so you know, this the constraints are: the expression consists of digits and operators, and the integer values of the input expression are in the range 0 to 99. Okay, the most difficult part of this question is actually the parsing of the expression. Okay, so let's look at this case. 2 minus 1 minus 1. One could be first evaluate this and then evaluate. Okay, so 2 minus 1 is 1, and then 1 minus 1 is 0. So you get this 0. Other way could be you could just do 1 minus 1, that's 0, then 2 minus 0 is, and this is all you can actually get from this. Now let's look at this case. So either you could do 4 times 5, then 3 minus 20, which is minus 17, and then you can do 2 times minus 17 to actually get minus 34. Or you could do is first solve this, then this, 2 times 3 and 4 times 5, and then do a subtraction like in this. Other thing could be you could just do this 3 minus 4 first, and then 2 times minus 1, then times 5, or 3 minus 4 times 5 and then times 2. So although this both cases would return you the same output, but let's say if this star was not a multiplication, it could have been an addition sign as well, right? So then in that case the answer would be different in these two. Now finally what you could do is first take this, then this, and then take finally this, and that is actually the way that we are going to do is, yeah, that is the way that we are going to do. First we have to generate all possible parentheses, and then we have to solve them. That's somewhat the idea that we are going to use. So here we are in my notebook, and let's see how do we actually do this, right? So first of all, either you could solve this and then this, as we just saw in the previous test case. You could have multiple ways of parenthesizing this, right? And you have to figure out the value in all the parenthesization. So how would you do? The idea that we are going to use is recursion, right? Using the brute force, which is given this multiplication sign, we are going to divide this into two parts, individually solve them, and then using those sub problems we are going to solve this bigger problem. This is a dynamic programming problem, so you have to figure out if you have the solution for this list and if you have the solution of this list, could you actually solve the problem, right? So that is the idea. So okay, so you're going to start traversing from this like this, and whenever you encounter an operation, you'll do the splitting operation and individually solve them. Fine. Similarly, after solving for this, then you'll go for this minus sign. You'll split this into two and solve for this. And finally, after you're done with that, you'll go to this last multiplication. You'll independently solve this 5, and then you'll solve this 2 times 3 minus 4. And this would actually give you the answer. So let's do one of the ways, right? So first I go to this 2 times this 3 minus 4 times 5, right? So let's break the recursion tree at this point. So we could have an element 2. So given a single, that is the base case, given a single integer, how could you actually do the solving of this? So the only way to parenthesize this is to return the value itself, right? Now what I do is try to solve this 3 minus 4. So 3 minus 4 times 5. So again I would do the traversing and I would break at this minus sign. So once I break this, I would have a single element 3, and at this point I would have 4 times 5 as the expression. So this is the base case, this is the base case, keep that in mind. Now when I go to this position, I'll just try to break it at 4 and 5, divide this into 2, I'll have a 4, so now given this expression, how many ways can you actually do the solving of this 4 times 5. Technically there is only, no matter how you put the parenthesization, the answer for two elements is the multiplication of these two elements, right? That you'll multiply this 4, and basically that is the idea. So for this, what I could do is I could just remove all of this and substitute 20 in this position. Now keep in mind I'm using square brackets to denote this is actually a list or a vector or an array. And how is this actually useful for us? You'll see it in a moment. Now since you saw we broke at this minus, right? So one of the ways for solving this list, right, is 3 minus this 20. So one of the solution is what? 3 minus 20, which is what? Which is minus 17. And this is what we get while if we break at this minus 1. Now we are done with this. And what I'll do is I'll start traversing to the right and I'll see this multiplication sign. What I'll do is I'll break again. So I'll get 3 minus 4 and 5 as a single element. This is the base case. Single element, the base case. Now how could you actually solve this? So this would be 3 and this would be 4. And how could you actually solve this? So there's only a single way for two elements, and with a single operation you can only have one possible solution. So for this 3 and 4, what I'll do is I'll subtract them. 3 minus 4, which is minus 1, and minus 1 would be our answer for this subproblem, and I'll remove. Now given this, you technically have the solution for this part and this part. So minus 1 times 5, this is what you get. So a possible answer for this would also be minus 17, and this minus 1 times minus 5, minus 1 times 5, which is actually minus 5. Okay, we are good till now. And now if you actually observe, for this I can just remove this and I could just write minus 17 comma minus 5, and this is my list. Now given this, so I have a solution. Given this subproblem, right, I can have two possible values for this this expression, which is minus 17 and minus 5, right? So minus 17 is by first multiplying this, and 3 minus this, and minus 5 would be first doing this operation and then multiplying this by. So this is the only possible way. Now I have a solution for this side, I have a solution for this side. Now how do I get the total solution, right? So the total solution would be what? Total solution would be 2 times minus 17, because from this we could get minus 17, right? So what I can do is 2 times minus 17, which would give me minus 34, and as well as through this we were also able to get minus 5. So 2 times minus 5 is minus 10. So if we are breaking at this point, right, we are breaking this expression at this point, we are able to get these two values. So that means we are first solving this left part, then solving this right part to get these two possible solutions. Now we are done with this part. Now we start traversing to the right and we see a minus. And since we are seeing this minus, I can actually divide this into 2, which is 2 times 3, not a square bracket, 2 times 3 and 4 times 5. So 2 times 3, which can individually be divided into 2 and 3, 2 and 3. Similarly, this would be divided into 4 and 5. Okay, so now we divided this into 2 and individually them as well. So how could you get the possible synthesization for this, which is only a single possible solution, which is 2 times 3. And what is that? The value is 6 here. And for this case on the right, we only have a single possible solution, which is 4 times 5, which is what? 20. So given this, what I could do is I can just remove this and do the update of 6 here. And similarly here, what I could do is actually do 20. Hopefully I am right in this case. And I could do is for this, if we are breaking like this, right? So left side is 6, right side is 20. So what you could get is 6 minus 20, which is what? Minus 14. And since this is minus 14, we have one more possible solution as minus 14. And now I can actually remove. Now the next part we have done. We have broken the expression at this point. We have broken the expression at this point as well. Now what we are left with is this one, right? Since we are left with this one, now what I could do is actually break them at 2 times 3 minus 4 and simply 5. Now I'll just be as brief as. Now I could break this into what? 2 times 3 and minus 4, or just 4, not minus, just 4, and this is actually a list. So 2 times 3, so only way you could actually get a solution from this is, and 6 minus 4 is 2. So 2 is a possible solution for this. Now I remove this, I go to this, I break it at this minus, I solve this 2 times 3 and then minus 4. So be 6, and from this 4 we could actually minus 4. So I did that incorrectly. So initially what we had, this is, if we break at this minus, we then get this 2, and if we break at this multiplication, what we would get is 2 times minus 1, which is what is minus 2. We get minus 2 in this case. So forgive me for this mistake. The order is exchanged, but the solution is correct. Let me just rewrite. This would be what? This would be minus 2 and 2, and this is 5. Now how do we solve for this whole expression? And for this we just do the multiplication element wise. This would be what? We would get minus 10 when multiplying this with this, and we would also get positive 10 by multiplying this and this. If you see, we are done with this expression, and now what we are remaining with is minus 34, minus 10, minus 14, minus 10, and 10, and this works well. Now one more thing that I want you to observe is this, right? The thing is, when you were traversing like this, right, once you broke at this position, you evaluated this expression, right, 2 times 3, as well as when you evaluated this, in that as well you evaluated this 2 times 3. So you have repeated sub problems, and what do you do when you have repeated sub problems? You try to memorize this, right? And that is what we are going to do. We are going to memorize this, and so that we don't have to do the repeated computation. Okay, so let's actually look at the code of how we actually implement this. And initially, if you don't do memorization, it's the time complexity is 2 to the power n, right? And for each expression you are traversing this, right? So n times 2 to the power n is the time complexity, and similarly, not similarly, and 2 to the power n would be your space complex, because you're storing individual expression again and again. Now if you memorize this, this would definitely improve. So I feel that would be about n square. If you memorize this, the time complexity, maybe you could get this to n square. I've not actually done the calculation right now, I'm just making a guess. So let's look at the solution and think this through. So we have this, so I'm using a map, right, for memorization, and since this expression is quite long, just for defining the data type, I'm just using a UMAP, an ordered map. I'm using typedef just to rename this to UMAP. So when this would be compiled, this UMAP would be replaced with different ways to compute. Is declare this map and call this recursive function defined. That would actually help. Now let's look at the private. If you see this, I'm just defining a solve operation which allows me to write this code efficiently. So left integer and right integer, let's say we have the solution for left and right, and we have the operator. We could actually do the solving. Left plus right, if operator is plus, left minus right, if operator is minus, left times right, if operator is multiply, and just return int min, because if you enter the wrong operation, let's say you'll get an int min, because this won't be ever reached in this particular example. You know, you only have plus, minus, and star. So that's one thing. And what's this diff compute, which is compute the difference, right? So first, a few things. If you find this expression, given the expression, if you find a solution, you directly return that, because it is assumed that we have already solved this. So that is for memorization. Here as well, if you have not memorized this, you'll do the solving, and after you're done with the solving, you again would add that to the map. Remember that you have to pass this map by reference. Now what you could do is, in the end, you would actually return the answer. And now let's understand what is happening here. Now we have to think the solution in terms of recursion, and the base case is actually at the end. So this is actually the base case. The order is different, I know, but it works. stoi is just string to integer. And now what you do is, we were traversing this expression, right? That is what we are going to do. Either you could use expression dot length or size, both would work. Now what you do is, you first determine what is the character that you are actually at, and if you are having a plus, minus, or a multiply, right, this is actually the operator ch. So you would first solve the left subpart, and then you'll solve the right. So what this does is, you assume that this function gives you the characters. So you pass the substring from 0 to I minus 1. Now the last number is non-inclusive, right? So you solve for this expression assuming that the operation is correct, and you solve for the left part and you solve for the right part. So you have all the possible solution. Given this operator, the left part of the operator can give you these possible list of integers, the right would possibly give you these possible integers, and what you would do is for all the elements in left and right would just perform the whatever operation you were given, left, that operation, and right, and that would take, and that you take back into your answer. Okay, now you go through this, and once you're done with that, the idea is if you see this plus, minus, or star operation, you know that the answer would have some or the other element, right? It would have some or the other element, because at any point of time whenever you pass the substring, right, this would have some value and the base case is just the element, so this would have some solution. Now in this, if answer dot size is 0, that means not of answer dot. So that means if the answers dot length that we have defined here is actually 0, that means in the expression we did not find a plus, minus, or a star. So that number, that expression is in itself a single number. So that is why the base case is just to add that single number. So now what I do is I store that into the map and I return. And yep, that was the whole video. I know this explanation took quite long. So you see test cases are accepted, it's 100%, and yep, that's all I have for this video. Hope I was able to explain to you, and thanks for watching. I'll see you in the next one.